We had earlier dealt with this topic on swapping. Battery swapping, I will say, is an India innovation. What is the concept behind this? The concept is battery is the primary driver of cost of electric vehicles, and actually battery is a container of energy, just like a empty gasoline tank in which you fill the energy and then use it, and once it is emptied you fill it again. Battery is like a container of electricity. But what is the difference? The difference is the capital cost of battery is very high compared to a petrol container cost. So therefore upfront cost becomes extremely high. And then the battery also has to be replaced, because container by and large does not get damaged, whereas battery will has a lifetime, and lifetime will depend on the charging rate, discharging rate, temperature, depth of discharge rates. And since there is a large capital cost, there is a large interest cost that comes in, and therefore that kind of hurts an electric vehicle. So we now propose a mechanism by which electric vehicle can be purchased without battery. And there is another big problem that we have briefly touched upon, is range anxiety. You are always worried about, are you going to complete your journey without having to wait for charging, because remember, battery charging is not fast. Unlike petrol pump filling, which can be done in a few minutes, battery charging ideally should take several hours. You can have fast charger which can do 1 hour, you can do faster than that, 30 minutes, 15 minutes, but still there is a lot of wait period, and therefore you are always worried, are you going to reach the destination or are you going to run out of battery. The advantage of course is, if you buy a battery per vehicle without battery and you lease the charged battery, then your initial cost becomes very low, and then you pay per usage. Very similar to what we do for LPG gas cylinder. We never buy the LPG gas cylinder, we buy gas in LPG gas cylinder. This is what is used widely in India. Now I remember about 35-40 years back, when this whole thing was getting introduced, the argument was whether you lay pipes to every home or you provide gas cylinder, and everybody was sort of saying no, following the West, it has to be pipe. Gas cylinder, taking every time, taking it out is just going to be too expensive, but it has worked extremely well. If you look at LPG gas cylinder, not only reaches most urban homes, today reach significant percent of rural homes, and if you would have tried to put pipes and with the leakage in pipes and the infrastructure cost, we would have been dead. Similarly, what if battery is provided to you on demand? Then you do not have to pay upfront for battery cost. Somebody else will buy the battery and provide to you charged battery. When it is discharged, we will take it back and again provide you charged battery. Remember, the petrol cost is high. In a petrol vehicle, though the tank cost is low, petrol cost is very high. For us, the advantage is the electricity cost is very low, energy cost is very low. So that is our advantage. If you do not have to pay upfront for battery, it can become a huge gain. And that is the time a concept came about 5 years back, that there can be an energy operator. Energy operator is like a petrol pump owner who will buy battery and put it, and will make it accessible as petrol pumps are accessible, almost any street corner. And there will be multiple outlets. You can tie up with any well, for example, any one of the petrol pump, or who is also now a battery swapping. Suppose you tie up with BPCL, you go to any BPCL outlet, you can get the battery that you need, just put it in, give your discharge battery, and then you go to another BPCL later on and again swap battery. That can make things work. This was a big India story 5 years back. Unfortunately, the way the governments are, different departments, they have not seen this in the West, and unless you see things in the West, you really do not trust technology, you do not trust our scientists, and they kept on kind of finding one reason or another. Of course, there are people who are opposing electric vehicles, some lobbies of the petrol vehicle, they also joined in, and for 4 or 5 years this was kind of stalled. Only in September, October of 2020, finally it dawned upon the governments that no, this is a good thing, and they approved it, and now the rules are being made trying to standardize battery, again getting into trouble, but anyway that is going on. What will be the time to swap the battery? No more than filling a petrol pump. 2 to 3 minutes for a small vehicle, maybe 4 minutes for a large vehicle. There will be no waiting time and therefore no range anxiety. If you can, within a few kilometers of where you are driving, if there is a BPCL swapping station, I am just mentioning BPCL as an example, and you have signed up with BPCL, all that you need to do is go there and swap the battery. Energy operator swaps the battery at multiple users, so that user convenience is there, and charging can be done at the swapping station itself, or could be the batteries could then be carried, charged and brought back. I think best is to do charging at every swapping station. What will be the charges that they will take? Of course, they will charge for the energy. If you have filled in 2 kilowatt hour energy, electricity, that much cost, but they also have to take into account the cost, capital cost and interest cost of the battery. Remember, the battery will have a finite lifetime, so many cycles. So, each cycle they have to recover certain costs, and that has to be added, depreciation and interest cost, to the cost of charging, and of course, the cost of operations, and that some profit, that is what they will be cost per kilometer. But one thing that I can assure you, this cost per kilometer for electric vehicle will work out to be much less than petrol cost per kilometer. Upfront you are not paying for the battery, your costs are much less than cost per kilometer, it is a winner thing. Of course, the energy operator will have to, if they are signed up with 50,000 vehicles, they cannot have just 50,000 batteries, but 50,000 batteries will be in use. They would use as much as 100,000, but if you really optimize, you can probably do it with 80,000 or 70,000. That is a work that can be done depending on the spread, depending on statistics of usage, one can determine this. Energy operator will invest in batteries, will invest in bulk charger. What is a bulk charger? A charger which charges multiple batteries. It will be like a wardrobe. You just keep on putting batteries, it will charge, because they will be keeping on getting battery, and once it is charged, it will be used. And the swapping outlets, they will procure batteries in bulk, that will drive down the cost, and energy operator will do everything so that the battery life is maximized. So, they will cool the battery while charging, and in a centralized outlet, in a wardrobe kind of thing, it is easy to cool that. Now, one can even do various other things. For example, some driver is driving very rough and hurting the battery, some drivers are not, they can learn that behavior. Remember that there will be probes on the vehicle and the battery which will be giving information every few seconds. So, you can learn and say the drivers which are using the battery well and therefore preserving life will be charged less. So, all those business models can be worked out, and there are different groups and companies which are doing it. For example, Esmito is looking at all those things. There could be a central management system for the energy operator which records the use of battery, records how much it has been used, how much a driver usage, where it was picked up, where it was dropped, how many batteries are waiting at any particular point. All those are optimization, interesting optimization problems. And by the way, Esmito is a company incubated by IIT Madras which has been doing something like this. Once by and large the concept was clear, there was another issue that was raised. What if happens if a driver takes the battery on lease and just walks away, runs away, or somebody steals the battery, opens and steals the battery? Well, that kind of gave an idea of what is called lock smart battery. What is a lock smart battery? The battery basically is designed such that it can only be charged by an authorized charger, which is at the bulk charger of the energy operator, or it can be discharged only by the authorized vehicle at which it is swapped. So, if another vehicle comes, it is taken out and used in another vehicle, it cannot be used, it cannot be charged, cannot be discharged. So, if it cannot be charged and cannot be discharged, casual thieves will not purchase, go with it. They may do it once or twice, but then they will say, oh, this battery neither can you charge nor can you discharge. What will you do? So, this lock smart, essentially there is a relay inside the battery which is turned off unless there is authorization, and the authorization can be all coded nicely. You can use blockchain to essentially open that battery. So, that kind of concept was introduced, and we had developed encrypted key exchange between charger, vehicle and the lock smart battery. By and large, it eliminates the fear of getting stolen. Of course, there will be lock, so it is not easy for somebody to do it, but lock smart battery will help a lot. The question then often comes, is standardization needed? Here helps in multiple brands of similar vehicles. Suppose there is a scooter battery. If all the scooter battery, all the two-wheelers, small, you can define one large size two-wheelers, one small size two-wheelers, uses the same battery, then the inventory required by the energy operator at each swapping outlet will be less, and mostly the battery will be available on demand. So, it does help to reduce cost because and improve this, but without standardization, our energy operator has to carry battery for each manufacturer. That will not be very good. But what needs to be standardized? There is a big confusion. There are people who understood this and say everything should be standardized. Everything need not be standardized. We will come to this in the next section, but to sum up, vehicle capital costs low, in fact below petrol vehicle if you do not purchase it with battery. Operation cost of electric vehicle equal or lower than that of the petrol vehicle. As frequent swapping may be needed, convenience is very important. Where do you put your outlets? Petrol pumps could be good to begin with. And since you can keep on swapping again and again, you can get unlimited range, there is no problem. On the day you need to drive longer, you swap it once or twice. The big advantage is that you can charge the battery now slowly, in fact 3 hours minimum, and charge it with lower temperature. Put that station air condition, that will prolong the life, will make the energy operator business look better. Swapping removes the range anxiety and makes small battery usable, and there is a large investment by the energy operator, but they will make money, business is viable, because when they lease our battery, cost per kilometer is less than petrol cost, taking into account all their costs and profit, and that is the big advantage. Now, I am going to come to another topic. This is often talked about, both about charger as well as about battery swapping. Do you standardize? What do you standardize? Why should you standardize? Lot of confusion. Actually, there is no need for so much confusion. If you understand a little bit of technology and economics, which you are doing in this course, you understand what is needed. For example, if I have an onboard charger, means charger is dedicated to my vehicle. then strictly speaking need not be standardized. It is for my vehicle, I will use it for my vehicle, it is there carried in the vehicle, and nothing needs to be standardized. Though I will say you will like to standardize a bit of it from volume point of view. If you are making 10 different models, and if you have charger for each model, that is not the best thing. If you from volume point of view, you may still standardize. Also, if multiple vehicle owner have a similar charger, same charger, then that reduces cost, because volume reduces cost, it is a cost of electronics. So, let us leave the onboard charging. Onboard charging, standardization is desirable, but let industry handle it. Off-board charger. What is off-board? The one you will put in public place where you can go and charge. That needs minimum standardization, so the electric vehicle may be chargeable. Otherwise, there is a charger only for a particular kind of vehicle. That is not desirable, it will never pay back. From investment point of view as well as user convenience, I do not want to go looking for. Wherever charger is available, I should be able to go and get it.